Hey friends, welcome back. Today we are doing something different. Instead of learning one theory topic, we are solving real caching interview questions. Questions that are asked again and again in backend and system design interviews. But most people memorize answers without actually understanding them. So today, we'll understand the logic behind the answers. And by the end of this video, you'll be able to explain these concepts clearly in interviews. Let's begin. First question, why do we even need cache? Short answer, cache reduces repeated expensive operations and improves response time. Now let's understand properly. Database queries are expensive compared to memory access. Imagine thousands of users opening the same product page. Without cache, every request goes to database, again and again and again. That increases database load, CPU usage, disk reads, latency, and cost. So instead of rebuilding the same result repeatedly, we store frequently used data in fast memory. That is cache, simple, clear, professional. Second question. If cache improves speed, then why not cache everything? Short answer, because cache memory is limited, expensive, and not all data is worth caching. Now let's understand why. Suppose one product page is visited by millions of users. Caching that makes sense. But suppose another product is opened once in 2 months. Caching that wastes memory. Also, some data changes very frequently, like stock prices, live counters, or bank balances. Caching such data may create stale data problems. So caching everything is actually inefficient. That is why systems cache only useful and frequently accessed data. Third question. What is stale cache? Short answer. Stale cache means cached data is outdated compared to source data. Now let's understand. Suppose product price changed in database, but cache still contains old price. Now users see outdated data. This happens because cache is temporary storage, and maintaining consistency between database and cache is difficult. That is why systems use TTL, cache invalidation, write-through, or update strategies. So stale cache basically means cache and database are no longer synchronized. Fourth question, why is cache invalidation hard? Short answer, because keeping cache synchronized with changing real data is difficult at scale. Now let's understand why. Many engineers say, there are only 2 hard things in computer science, cache invalidation and naming things. Because when real data changes, we must update or remove old cached data everywhere. Now imagine, thousands of servers, multiple cache layers, millions of users, timing issues, race conditions, and partial failures. Now keeping all cache entries correct becomes difficult. Speed is easy, correctness is hard. That is why cache invalidation is considered difficult. Fifth question, what happens if cache fails? Short answer, if cache fails, traffic suddenly shifts to database, which can overload the system. Now let's understand. Suppose Redis crashes. Applications usually fall back to database, meaning requests directly hit DB, but now danger starts. Because database suddenly receives huge traffic. This is called cache overload situation. And sometimes database itself crashes under pressure. That is why companies use replication, backup caches, rate limiting, and gradual recovery strategies. So today we solved 5 important interview questions. Why cache exists? Why not cache everything? What stale cache means? Why invalidation is hard? And what happens when cache crashes? These are not just interview questions. These are real engineering problems. If this video helped you, like the video, subscribe to the channel, and in the next part, we'll solve more advanced caching interview questions, like cache Stampede, Redis versus Memcached, LRU, and distributed caching. See you in the next video, where we make hard topics easy, actually.